Welcome back, dear students. Let's continue with the properties of definite integrals. So you remember in the last class we were making use of the property P4, right? So in today's class also I'll be, especially in this particular problem, I'll be making use of P4, right? So I know, or with the assumption that you already know P4, let's solve this, and for that I'll be removing this from here. Okay, right. So let's see. So here what you need to do is, so first we'll take, okay, so we'll take, let I equals to this integral 0 to pi by 2 a square cos square x plus b square sine square x dx. Let me call this to be equation number 1. Okay, now if you apply P4, what you get is the limit will remain as it is, so it is pi by 2. Here you will find some changes. Okay, so the change that you are going to have is, in place of x we'll write pi by 2 minus x. Okay, that is a minus x. So pi by 2 minus x plus, similarly we have b square sine square, in place of x I'll write pi by 2 minus x. Okay, so let me close the bracket. Okay, now all of you know this is 0 to pi by 2. Now cos 90 minus theta is sine theta, so that's why this becomes a square sine square theta, that is x, and similarly this becomes b square. Now sine 90 minus theta is cos theta, so that's why it becomes b square cos square x dx. Okay, so you know this is your I and this is also your I, and let me call this to be equation number 2. Okay, now what will I do is I'll add 1 and 2. So let's see what do we get after adding. So adding 1 and 2 we get, so we get I plus I will be 2I is equal to, so first we have, so let me write this entire equation. So we have 0 to pi by 2 a square cos square x plus b square sine square x dx, plus we have this from the second one, 0 to pi by 2 a square sine square x plus b square cos square x dx. Okay, now after you see here we have got the same limits, so that's why what I can do here is I can combine both of this integral. Okay, so when you combine, what you see here is, see here carefully, you see that from these two, from this one and this one, a square is common, right? So when you take a square common, then you get cos square x plus from here you get sine square x, isn't it? Now similarly from this one and this one, you see b square is common, so b square is common means you get sine square x plus from here you get cos square x dx, isn't it? Now if you observe here, you know cos square theta plus sine square theta is 1. Similarly this also becomes 1, so that's why this can be written as 0 to pi by 2. So this is just a square plus b square dx. Okay, because this is 1, this is also 1, so that's why, see here, let me do the rest of the work here. Okay, so we get 2I equals to, okay, so you bring this constant outside integral sign, you get a square plus b square integral 0 to pi by 2 dx, right? So from here just keep I here, so it becomes a square plus b square by 2. So this becomes x, integral dx is just x, and it is 0 to pi by 2. Okay, so when you apply the limits here, it becomes a square plus b square by 2, so it becomes pi by 2 minus 0, right, which is nothing but pi by 2 minus 0 is pi by 2. So when you rearrange this, this becomes pi by 4. 2 into 2 is 4 into a square plus b square. And that's what I want to show, right? So you may pause the video and note down your solution. Okay, let's have this problem. So for doing this problem, see, if you look at the limits, here we have -1, here we have +1. So it looks somewhat like this, yes? Okay, but whenever we have modulus sign, we will not go for this. Okay, so whenever modulus is there, we'll always go for P2. Okay, so we'll always go for modulus for P2 when there is modulus sign. Okay, so why, you will understand this here. Now we know that modulus x will be equals to x if x is greater than equal to 0, right? And it becomes minus x if x is less than 0. Okay, so basically, see, the limit is given to be from -1 to 1. So basically, in a real line, you have to integrate from -1 to 1. Okay, but this function is breaking at 0, isn't it? So 0 is lying somewhere over here. So that's why what we are going to do is, see, we have -1 to 1, right? So what we'll do is, we will break this function into 2 like this. Okay, and we'll break, after breaking the function into 2, we'll break into 2 integrals like this. So basically, in this property, if you see C, this C is actually lying in between A and B. Okay, so that's why, therefore, this integral -1 to 1, okay, so this can be written as, okay, so if I write mod x to be equals to x, okay, if I write mod x equals to x, then what happens? Then your limit is from, okay, so let's do one thing. So let's do one thing, and let's not write this here. So first, let's divide this interval. Okay, so it is from -1 to 0. Okay, and we have plus from 0 to 1, from 0 to 1. Okay, now in between -1 to 0, the value of x is negative, right? So when x is negative, then mod x becomes minus x. So that's why I'll write minus x here. Okay, and from 0 to 1, the value of x is positive. From 0 to 1, the value of x is positive. So that's why, in case of positive, the value of mod x, whenever x is positive, the value of mod x becomes x. So that's why I'll write x here. Okay, so basically, how much is this? So you can take this minus outside. So it becomes -1 to 0 x dx plus 0 to 1. So it becomes x dx. Now all of you know the integral will be half x square, right? And we have got the limits here. Okay, plus similarly it becomes half x square, and the limits are also given. Now let's put the value of the limit. So it becomes minus, okay, so 0 square minus -1 square plus half into, this becomes 1 square minus 0 square, right? Okay, so you know this is minus half. Okay, so 0 square minus, now -1 square is plus 1. So that's why it becomes, this entire thing becomes -1. Okay, so it becomes -1 plus we have half, and this becomes 1 minus 0, which is 1. So minus half into -1 becomes half. So it becomes half plus half. So what is half plus half? It is exactly equals to 1. So that's why the value of this integral turns out to be 1 by using P2. Okay, so you can mention this also here. Okay, so using P2, you can mention this out here, right? So you may pause the video and note down your solution. So we have one more thing here. Okay, so by the way, we wanted to show that our answer is 1, and we have already shown that is 1. Similarly, here also you need to do the same. So I'll just do half part of it. The rest of the part you will do by yourself. So in this case, what you need to do is, you will do substitution. So let 1 minus x is equals to, let's say, t. Okay, so from here you get minus dx is equals to dt, which means that dx is minus dt. Okay, now as you are doing substitution, you need to change the limits as well. Okay, so see, this is the value of x, remember. So when x is equals to 0, then okay, so when x is 0, then what will be t? T will be 1 minus 0. 1 minus 0 is 1, isn't it? So then t will be 1. Okay, now when the upper limit is 2, so when x is 2, then t will be, so when x is 2, so it will be 1 minus 2, which is minus 1, isn't it? So that's why, therefore, this given integral 0 to 2, 1 minus, it is modulus of 1 minus x dx can be written as, so in place of dx, if you write negative dt, that negative can be taken outside integral sign. Okay, and this lower limit. Okay, so first and foremost, you know, it becomes mod x, mod of 1 minus x is mod of t, and see, as I told you, dx becomes minus dt, minus is outside, so only dt will be left. Okay, now the lower limit is 1, okay, and the upper limit, that's 2, becomes minus 1. Okay, now if I make use of, let's say, p1, see, when you interchange, see, this a is lower limit here, a is upper limit here, b is upper limit, b is lower limit. So when you exchange the limits, the sign will get reversed. So that's why if I exchange this, okay, so if I exchange this, this comes to the lower limit and this goes to the upper limit. So that's why this minus becomes plus here, others will remain as it is. Okay, so this is using p1. Okay, now look at this question and this question. Aren't they same, right? So I think from here onwards you will be able to do by yourself. Okay, so you may pause the video and note down your solution. Okay, so this is a special kind of sum, and I think for today we'll leave till here only. From this question onwards, we'll be making use of P7, very important. Okay, and we'll try to cover these problems in the next class. So with this, we close for the day. Thank you very much.